Wasm compilation is on main stage, and one speaker is not available, so we moved it to main stage, and I just jumped into the moment and prepared a bit of testing, and I will share some minutes. So don't expect fancy slides. I haven't had much time to prepare, but there's one slide from my other talk that I wasn't able to show, so I'll show it to you and explain a couple of things. Also, hopefully you can be able to dive a bit into code and share my passion about testing, the right test. It's early, so I'll still wait some minutes before I start.
It's coming.
It's on main stage. So the schedule was modified, but you're more than welcome to join testing. Doors are locked, sorry. So, yes, as I said, this presentation comes from passion, working on projects, also about helping people to write, let's say, the right tests, not random tests, not making your life harder, but just making it better for you, for others, especially if you're working on open source and there are expectations on quality, and we also want to ship things in decent quality, and it's not easy to ensure that. Yeah, so it's from 0 to hero. So we had to come up with a title today, and so thanks to Pino, so he helped me with that, and yeah, let's start. Some words about myself. So I am Alexander Peters. I work with ComFu as a Go backend engineer. I worked on several projects in the Cosmos, T-Grades, WasmD especially, the mesh security project, and a lot of other projects. But before I was in blockchain, I worked with many startups, also enterprises. I worked as a consultant, and therefore I've seen a lot of tests. I've seen people spending weeks writing tests, and I deleted hundreds of tests for the team, and so I did a lot in tests. And yeah, let me start with some basics. Speed versus quality. That's a common thing. You have that in every project. You have one side, you have the product side, that they want their features shipped fast as possible. But then you have the other side, so the people are actually doing it, and they are sometimes a bit worried that could go wrong, maybe, but we haven't tested it yet, and yeah, sure. So there's always this, let's say, little battle, what is important, speed or quality? And there's no simple answer other than both. And just the question, what is the right quality and what is the right speed? And who owns what? And so from my experience in startups, I have learned, as an engineer, you usually have to focus on the code, which is great, but you don't have your focus on the market. This is what the product team does, or maybe the salespeople, or whoever has a completely different thing. And sometimes it's very important to ship it tomorrow. If you ship it 3 days later, then it doesn't matter anymore. But as an engineer, I also know, okay, if we ship it tomorrow and we haven't fixed that, then this will generate tons of follow-up work. The database will be a mess. We'll be spending 2 weeks just to get into a state that we can work again. So how would you deal with it? And yeah, from my projects, I found best to think about this as an onion. So you have a core, something that will last, something that is built there for a very, very long time. You don't touch it very often, you sometimes do, but if it breaks, it hurts. And this is, I mean, if you have customer or the customer data, that's something definitely in the core. But if you have something like a campaign, something that runs for a week only or 2, and then you can drop the code, that's a completely different thing, right? You know, okay, it has to work somehow, but you're not dealing with it forever. So this is more on the outer side of the onion. So when you build new features, you can use this as a template and discuss. So where do we put that? So where should this feature go? Should it be on the outside or more on the inside? Are we going to live with that? And of course, the product team will ask, okay, what gives it me faster? So we're always pushing for the outside, but the engineers want it covered well, but there are different things or tests you can use to cover it still. And but this is a more, let's say, healthier discussion. Yeah, also gives a perspective that this code has some lifetime, and it's also helping to manage expectations on both sides. And yeah, but what are the right tests? So this is let's say, typical consulting picture, and not the test pyramid. You have the foundation of unit tests. Unit tests cover small features, units of work. You have a lot of them. They run pretty fast. They give you confidence that you don't break things, and you just have a lot of them. Above there are the integration tests, they cover more, but take much longer to run already than compared to unit tests, but there are reasons to need them. And another level above, there are the system tests that hit the full stack. You cannot avoid that, but it gives you the confidence that that things are running as they would run on production. Yeah, so if you're talking to a web page, you somehow need to talk to it in the test once so that it works. And above is usually a picture of a cloud with all the manual tests. So there are things you can hardly avoid. For example, if a button has the color of the background, it's hard to spot for a human. A test that picks it by an ID will probably pass. So there needs to be a balance of manual tests as well. So usually you have some kind of manual gate where somebody checks that it works, especially for new features or during the development process. That makes sense. And in practice I've seen, of course, the opposite, where you have a lot of long-running system tests, a lot of manual things, and only a small number of unit tests on the ground. That's the ice cream picture that's usually shared in this context, but let's be optimistic, so we have a pyramid already. But what are system tests, integration tests, and there are so many names for tests, and I'm also not sure if I always use them right, but let me show you how I use them here. So on the left you have the client, you have the chain, blockchain, you have smart contracts on the right, and you have, let's say, these little boxes between they are some unit of work that is executed. Each of them can be tested individually. So like you have, for example, you pass a string, you want to ensure that the string conditions are met. Or in Cosmos or in blockchain context, it's more a message. You have some validate basic method, which ensures that some basic constraints are met, and then you do a test to just confirm they are working. And you have a lot of them, because they're easy to write, they cover a small context only, and they're fast to run. And important is that you write enough of them, because when you start to write, to chain them, or think of them as a chain, then it gives you confidence that the parts do not break apart. So you start here with this test, with this unit of work, this may call a second unit, a third unit, and so on. And when each of them has their tests, so for their specific part or domain, then you have pretty good confidence that you cover the edge cases and have everything built. But once you start skipping this, so you have a blind spot here, then you cannot trust the chain anymore. So that means going shortcuts can be very expensive in the end. So working with open source projects is sometimes a bit challenging with external contributors, as they like to get their features in. They work on the feature itself, but they don't see the need for the test, for example, because the code change is so trivial that it's easy to read, easy to spot, to understand. It's maybe 1 or 2 lines of code change only, but there is no need for the test in their eyes, and I do fully understand that. But if you have a different view on that, see this as a chain, then you don't want these blind spots, and therefore it helps to invest in these tests. So cannot always ask the contributor to do that, so sometimes I write the test myself, but it's usually a good thing, and all contributors in WasmD are very, very helpful and in trying to support this model. Then there are the boundaries of the system. So you have some client, whatever this is, so it can be CLI, can be a web page, can be anything that talks to a system. You have, on the other side, you have in classic web applications, you have the database somewhere. With the AwesomWasm chain, you have contracts, and here again, you have your units of work, you test them fine, and so you have confidence here. But there are the boundaries, so where from one system to the other, you move data, you query, you execute something, and these are the integration points. So, and at some point, you have to test them. You have to hit the database once to ensure that the database connection works, and it's the same for contracts. If you skip that part and have pretty good confidence and coverage of your chain, but you're missing the integration parts, then how do you know that things are working? And it's not super expensive to do these tests. So in AwesomD we use the keeper. So this is the point where we interact with contracts. There are some example contracts built that we use to just trigger some messages. We send them from here to a contract. The contract returns the message over the query. We get the response back. We make a check mark and have covered quite a lot already. We're not going into edge cases there for AwesomDM, for example, because that's a different project that has their own chain of units, unit tests. And we can trust that it's done proper, or let's say we have to trust that. It's the responsibility of that project. And on the other side, you have, for example, Tendermint or PrometheusDFT, you have the SDK, and probably there's more like the RPC stack, and so on. We're not testing that either, or the edge cases either. There are assumptions that these things are working and covered proper. And you should ensure that before using it. And therefore we do what we test and what we can control, what we can influence. And so there are a lot of unit tests, and their integration tests, there are probably, for historical reasons, more integration tests than needed. So we're doing quite some ping pong here with the contracts, but that's fine. I mean, it doesn't hurt us yet. We don't have the problem of super long running tests. But as I mentioned before, at some point you have to click on the web page, or you have to execute something end to end. So therefore, there is need for system tests. A system that runs itself, hosted somewhere, so that you can trigger it and execute something as a black box. But here again, you don't have to go for the edge cases. The system tests are super slow compared to unit tests, so therefore you only want to have a couple of them. But yeah, they should have confidence the stack as its total is working as expected. So therefore, you do smoke tests, so just, you know, it is working. You focus on the happy parts, so don't go for the edge cases. Or just if you have some business model where some things have to work, and if they don't work, it costs you immense amount of money, then build a system that's for that too. Because that's a different reason. It hurts the company. It's important to cover the risk. But the amount of system tests should be kind of small compared to the others, and yeah, they affect runtime quite a lot. I split this a bit on the contract side because there are a lot of frameworks. There are some frameworks now with AwesomWasm, and there are some ideas here, so that we do different kind of tests here as well. So looking at the contracts, you have the unit 2. This is done with Rust tests. Then you have scenarios where you have contracts working together. So one contract calls the other and gets a response back, and so on. So you're crossing the boundary of a single contract. So, and here we have some multi-test framework that helps with it. And you can write tests there too. They're of course not the same as unit tests here, but you can see them as then there are system tests. I had mentioned them as some code to share. So we had written them with Fortigrade because there was a lot of work in the UE module and so on that we wanted to ensure. And the system tests were ported to the AwesomD more recently. So we have confidence there too that the whole system is working. It was actually nice to port them to see what's working, and we also played back some bugs from other teams that were discovered by just running tests, and that was nice. Yeah, so there's also the scenario when you have multiple chains running in IBC context. Yeah, so you have chain A talking to chain B. And here we use the IBC testing framework. So the IBC Go team has this amazing testing framework with a coordinator in there as a component that can spawn on chains, so the number of chains, and you can then use the framework to submit messages, packages, IDC packages from one chain to the other. And we've extended a bit in AwesomWasm, so it's kind of a fork, but we're using most of the IDC Go framework there. And this is a different level of testing, right? So you want to ensure that the IDC things are working within WasmD, and to do this proper, it helps to just have a second chain, so do it end to end. Same for the contract. So we have a IDC contract here, we do all stack and back to the other chain, the second contract. And this gives us high confidence that we don't break things in the future. Because it's easy to write a feature, most of the time, to test it proper package, but to not break it in a future release or in the SDK upgrade and so on, that's quite some hard work. Therefore, we have a lot of tests for sometimes very trivial things that are there for regression. Yeah, so that we're on the safe side. If there are changes in the SDK or some fundamental assumptions are different, then these tests will fail. I think covered a lot of already. So simulations. Simulations is this tool. This is a test framework coming from the SDK. And the simulations are further tests. So furthers are just generating random data and then submit them into the system. Of course, the address cannot be completely random, so there's length. So the simulation provides, let's say, some kind of valid data, but random valid data into the system. And this is helpful as well. And the best thing here is that each module can provide their own set of tests. So that when we have a demo application in WasmD and execute these simulations, all the integration of the bank module, of the staking module, and so on are covered too in this simulation. This gives us confidence that the app setup, the wiring of the whole stack is done correct. So therefore, a big shout out to them too. Well done. Although I know simulations are super slow and there are some issues with them, but generally speaking, it's wonderful to have them, especially that each module can provide them. And in WasmD, we have covered a lot. There are still some blind spots. So for example, chain upgrades. So we're not able to test chain upgrades. That's a bit of shame because they're important, but we relied on this, on the community. So there are multiple blockchains running our work, but they have their test nets, they have their legacy data, production data transferred to test nets, and they should be in a pretty good position to just execute an upgrade and run it with your old version, have all the data there, then do the upgrade and pay back that things are working or broken, whatever. There are things that are not within our control. And it was similar with the system test. Before we said they were introduced quite recently. Just because of the need, we need a multi-node environment to test some of the work. But that part is not working super great. So I would like to encourage all the chains that are using our software. Please help us with the chain upgrade and other things. When we have a new release candidate, please deploy it into the system, run your test suites on them, and give us feedback because we cannot cover everything. There are always some blind spots, but we do a lot of work to ensure that it's smaller, our system is stable, and you have some very high quality on things. But as I said, chain upgrades, there are some ideas I thought an issue to get us on the track too, so that we cover the blind spot at some point. I also want to do a quick shout out. So I learned about TestTube recently. That's something amazing for contract developers to write the Rust test that hits the not the full stack, but it hits most of the chain. And so therefore you can test even more than you can do with multi-tests. There's Starship. Yeah, so our system tests, they spawn small environments, so like 4 nodes, 5 nodes, what you can configure, but 4 nodes are minimum. in the default, and so that you can kill one and see the system later on. And there's Starship. Starship is something new, and it runs on Kubernetes, and you can have it to set up multiple chains. And that's some amazing development too. So please look at these things and try to contribute, make them more generalized so that they can be used with other chains too. I have some, I have some code here. I can, I don't know much, but just quick look at system test. So the system test they run binary, so it wasn't the binary on both sides. So we're not really needing wasn't here, but the binary of wasn't. So there's quite some framework built around to make it easy to use in the test. This is a simple test that just covers delegates. So that's something that's not really part of our domain. So what I've said before, we should not test the SDK and so on. But as it was ported from T grades, there was some high needs to cover it. We copied it and just have it here in the state, so we have this covered too. The first line, I mean, there's some, let's say, some kind of setup happened before in the test main, which just spawns a multi-node test mode. You know, so not much code here, but this will just reset. And this is executed before this test. This will just ensure that the chain is in clean state. You know, so you don't want the test to fail because another test that left some data there, so it must not be dirty. Also some abstraction on top of the wasm memory, just to make it easier in the test to do some operations like send a message, get a key. We'll see some of them. So with this one, I just get the address of my key account one. Yeah. So it's added to the key set, and I have it here for my test. So the purpose is to have a richer framework, test framework, and don't have a lot of things in the test, so that when you look at the test, you should be able to understand them as a human. We'll modify the genesis. So we have this new address here, so the address should have some points. Then the chain is started. It will be 4-node chain, fully running on the local box. There's a query executed. Also, this is a wrapper around wasm So on CLI, you can run the same wasm fuse, data, you get back in this. I execute the stateful command afterwards. I pass my own data address, which was here from the query, and I also pass the address of my key. I expect the transaction to succeed, which was nice and also easier with before 47, as there was this block option. So I submit a transaction, it's blocked until I get a response of data. So this is still the same syntax here, but we wait for the next block in the underlying code, and then yeah, so that we have a similar behavior as before. I query balance, I ensure it's what I expect. I do another query here for the staking and make some assumptions. And you can see we're using the JSON framework here because dealing with JSON, yeah, something that isn't great in Go, and but it's nice in JQ, for example. And so there's a simple syntax to just navigate through the JSON. So it's balance elements dot is for a sub-element and it's the amount. So, and just compare that, and but you see, I mean, this is all within the wasm project test system, and it's still early stage. I think it's the binary, the wasm binary name still hard-coded there, and so there are no extensions or anything. But there isn't been done much to make it more generalizable. But if you look at the test here, there isn't anything very, wasm specific. This test would run with a different binary as well. So I shared this with some people already at some talks, and we hopefully make some effort to make this available to more chains. And hopefully at some point there can be a rich test suite of system tests, which can be similar to simulations, but very up to the community how we want to proceed. First, it's important. So as we are not owning the production network, we need some way to confirm that our binary is working. So end to end, everything covered. I do a quick jump now because there's another kind of test that I mentioned before, which are the IBC tests. And they are also super valuable, and especially if you are in early development phase, so like with mesh security, they give you a lot of power to test workflows end to end. So they are multi-chain environments, and this is an example. Yeah, this test needs refactoring, a lot of refactoring to make it nice and readable as the other. But it was more important to give confidence that to the contract team that the general model of provider-consumer chain does work, that the contracts can be set up and the packages can be relayed and so on. So therefore, bear with me, this test is not nice to read compared to the other, but there will be more abstractions, there will be a nicer reader, and it will be more readable in the future. But I just wanted to share it in this topic because it's so powerful, and do the right test at the right time. So there are no unit tests for that, there are no, let's say, system tests, so don't need multi-node and so on. This is just confidence that the contract process does work as designed. We use a coordinator, let's say modified coordinator. We have two chains, a provider and a consumer provider chain. There's a bit of setup for IBC instead of connections. I bootstrap the contracts on the consumer side, so I have some kind of abstraction already there. So it's not helping to see that you have 4 contracts set up. If you want, you can always dive into the code here, but for the test, it doesn't really matter. Fetch support for the converter contract, and then here the IBC connection is prepared for general config here. So the port of the provider contract, as well as the external staking, and on the other side we have the converter. And a channel is created so that the system is ready for IBC. And on mesh security, the MVP, the consumer side will send the current validator set to the provider side. So this is to fail fast and have some validations there. And this is the first thing that happens. So I assume, let's say I require in my test that this operation was triggered by the create channel. So the pending packages on the consumer side must not be empty. Then I relay them and have an acknowledgement. Then I can query the contract later. And so on the provider side. So I have confidence that provider and consumer side are set up proper. Both chains are ready. Packages do work. The contracts do work together and so on. And of course, we can do more. In this test, I've copied more of these high-level workflows. So I do a local staking, do a remote staking, do stable rewards, do an undelegate and so on. But it looks like this now. You don't want that, right? This was what I meant. Do the right test at the right time. So ugly test, but to give confidence play back to the contract team, and take this as to do to make it better as soon as you are able to do the next steps in the project. And it would be similar for my web application example. If you have a 2-week campaign, why spend time to test if you know they are going to be thrown away in 2 weeks anyway? But write a test which is ugly, which covers your use case, and then be confident that you have the right quality. There's always a question: who owns it? And the best answer that I've found so far: quality is owned by the team and the developers. They need to stand up to ensure that if they don't do products, has a focus on shipping, which is great, you need that. But the quality is something that the engineers have to stand up for. Otherwise, it will be a lot of work. And there can always be good reason to ship with, let's say, the 80% solution. 20% can be handled in the call center, for example. Give them a nice voucher so that they to compensate for the inconvenience, but do it then later. So these things will sum up. But with blockchains, you don't have the problem. So do the right quality, and when you ship your stuff, feel confident that the work you've done pays out too. Okay, that was it. Thanks a lot. I'll be around at the Confi booth or somewhere else here today, tomorrow at the hackathon, I guess. And yeah, happy to follow up on things. Look at the other open source projects like this. So Starship, yeah, TestTube, and yeah. Next time, see you then next time. Thanks a lot.